Hey there, how's it going? My name's Ross Parsons and I am a graduate student at the University of Idaho. So just like you guys, I am a student. I'm studying science. So I'm standing here wondering how I can measure the height of this tree, or perhaps the diameter of this tree. So to measure the height, I could have my friend climb up there like a monkey, but I'm kind of concerned about my friend's safety. I don't want my friend falling down, right? But measuring the diameter, I could have my friend do no problem. But what if I wanted to measure the diameter of this tree without ever touching the tree, right? So doing so remotely. Well, I could use remote sensing to do that. And remote sensing is taking measurements without ever touching that object. So you are all familiar with cameras, right? Take a picture of the tree and look at it. I can see what color it is, maybe what that tree is made out of, maybe some of the bark characteristics. That is called optical remote sensing. Perhaps you're familiar with Google Earth. That is also optical remote sensing. Today, we're going to talk about a different type of remote sensing called LiDAR, which stands for Light Detection and Ranging. Now, using LiDAR and using lasers, just like this one right here, I can create a 3D image of this tree in a computer software by taking and recording multiple points. So I'm going to instruct you guys on how to do basic setup of the LiDAR unit, as well as take a few points of data. So first, I want to make sure my tripod is completely level, right? So right here, you can see a circle with a bubble floating around in the middle. And I want to make sure my bubble is right in that black circle. To level it, for example, if my bubble is over there, I want to raise the tripod over here. And likewise, if the bubble is on this side of the circle, I want to raise it over there. So you want to raise the opposite side of where the bubble's at. Next, I want to make sure that my LiDAR unit right here is in its home base 0-degree position. Okay? So as you can see, my zenith angle, right, or what I like to think of as the up and down, my zenith angle is zeroed in, 0 degrees. I'm also going to line up my azimuth angle, the left to right angle, at 0 as well, at a marker right here. Now that I have my LiDAR unit, that azimuth and zenith angle at their home base 0 degree, I want to zero the digital protractor and my digital angle gauge. Digital protractor measures that back and forth azimuth, and the digital angle gauge measures that up and down zenith. I have it in the home base. I'm going to turn both of them on, and I'm going to press the 0 button on both of them. So both of them, the protractor and the angle gauge, are reading 0 degrees. Now I'm ready to take some pieces of unit. Perhaps I want to find out the diameter of this tree. Okay? So I'm going to take the LiDAR unit and I'm going to turn on the laser. I'm going to get a guiding point and I'm going to point it at the left side of the tree. I'm going to make sure that the laser is set to meters, right? Because we're global scientists, we want to think in meters, not feet. Pointing the laser at the left side of the tree and tightening everything down, I'm going to press the red button. And I can see that my distance is 1.804 meters. So I'm going to record that in my D section, my distance. 1.804 meters. I'm also going to record the A, my azimuth angle back and forth, which is at 43.2 degrees. I'm also going to record my Z, my zenith angle, that up and down, which is at 74.9. Great. Now I'm going to get that second piece of data. I'm going to rotate the laser, changing the azimuth angle over to the right side of the tree. Going to point the laser on the right side of the tree, tighten everything up, press the big red button. It's telling me I have a distance from the laser to the tree of 1.796 meters. And my azimuth angle, that left to right, is 46.6 degrees. And my zenith angle, that up and down, is 77.1 degrees. So here I have my polar coordinates. I'm going to be changing these into my Cartesian coordinates, my X, Y, and Z in Microsoft Excel, and viewing this information on Cloud Compare. All that will make sense here in a few moments. But this is just one example of things I can do with this LiDAR unit. So I'm challenging you guys in this lesson to think of something that you're particularly passionate about. Maybe you really enjoy fishing and you want to find out some characteristics of streams. Maybe you really like playing basketball. Well, we can visualize a basketball in a 3D way in a computer software. What sorts of things can you find out about a basketball and its 3D shape? Or perhaps you really just like playing around with your friends. Maybe you guys can measure distances from everybody's left side of their head to the right side of their head and see who has the widest head or the biggest ears or something goofy like that. So I'm challenging you guys to find something that you're passionate about or something that you like having fun doing and using the LiDAR unit to view those images in 3D and be remote sensing geniuses.